Howdy, it's Mr. Russell, and we're going to talk about our first real pre-lab. So it's about relating mass and volume. So I won't go through this whole PowerPoint, but it's posted in your Schoology page. For the whole PowerPoint is there, but you'll also need your workbooks that are here. So you'll open those workbooks in Unit 1 up to page 5, up to page 15. Page 15 on your Unit 1 workbooks. So let's start off by asking ourselves, why do some things float and other things don't? I mean, if you look at the picture, you've got liquids here, and you see lamp oil is on the top, rubbing alcohol, vegetable oil, water, dish soap, milk, maple syrup, corn syrup, and honey. So those are all liquids right here. And then these are all solids, like a ping pong ball. Well, that one's on top. But the soda cap, you can kind of see it's right there. Some beads are floating in this layer. There's a cherry tomato. There's a dye, even though you really can't see it. A dye is the singular form of dice, popcorn kernel, or a bolt, right? Or why does a ship float? Why does the Titanic float? Well, the reason why some things are separating from each other is because they have a different density. So density is just a function of just mass and volume. So this is how we're going to try to investigate this. So what happens here is this one has a lower density, so it's going to be on the top. The ones that have a higher density is going to be on bottom. Very similar thing happens to hot air and cold air. Hot air has a lower density, so that's why hot air rises, okay? So we have density is mass divided by volume, and in your experiment, these will be your independent and dependent variables. We will pick them in a second, but these will be your variables right here. And your goal is to be able to calculate the density. So mass is usually grams, but can be kilograms. And then volume is usually milliliters, but it can be centimeters cubed, which is the same as milliliters. Or it could be liters, or it could be decimeters cubed, which is the same as liters. Okay. Now, it is also what's called an intensive property, and that means that it does not matter what amount there is. So the density of water in a bathtub will be the same as the density of water in a swimming pool. As you increase the volume, you will increase. As this number increases, this number will increase as well, which means that this number will actually stay the same. So it does not matter how much there is sample we have. So as you can tell from the Titanic before, when it starts to take on water, well, it starts to get way more mass, right? And since it has more mass, the density will increase. And if the density of the ship is too high, and it's higher, and if the density of the ship is higher than the density of the water, then the ship's going to sink. Okay, so that's how that works. So I told you before that you will have two variables, right? And so you will have mass and volume. Those are your two variables. So when you think about drawing your graph, because you will have to draw a graph, you're going to have to pick your variables. Now, we all know that because of the dry mix, the dependent variable will go on the y-axis and the independent variable will go on the x-axis. We need to choose which one's going to be independent or dependent. Well, for y, you could have volume as volume, and then for x you could have mass, or for y you could have mass, and then x you could have volume. So, well, let's think about this for a second. Since density is mass divided by volume, and we can also take the slope of a line on a graph, that y over x, the rise over run, or the y2 minus y1 divided by x2 minus x1, all that stuff you did in algebra. Well, we can take that and we could think, uh, which one should be y, which one should be x, right? Kind of maybe combine these two. So what variable should mass be, y or x? It should be y, all right? And then what variable should volume be? It should be x, okay? So what we're going to do is we're going to x out that one right there. That one's not going to be what we're going to do. Mass is going to be on your y-axis. Volume is going to be on your x-axis, okay? So that's what it's going to look like, and this is going to get you ready for your pre-lab. So the idea here is online students will start to look at your density interactive, which is a PHET simulation. So I'll give you a link to this, and you will take your density basically virtually. So you will still have to write a procedure, but that is your goal. That's your homework over the weekend. It's due Tuesday. I'm sorry, it's due Monday night at midnight on September 7th. Okay, so that due date is subject to change. I'm not. That's not. But yeah, I'm planning on making it due the earliest then. Okay. So I want you all to have a great day. You will be able to check through the rest of this PowerPoint as you go. But if you have any questions, please make sure you zoom in with me at my tutorials on Tuesday or even on Friday. Okay. Have a great day.